Now that we've written out some code to deploy our contract, let's break this statement down right here and figure out exactly what it's doing. Remember, this is all code that is tied to the Web3 library, and the Web3 library is our sole means of interacting with an Ethereum network. It's really our portal to everything that's going on with Ethereum. So we're going to take this code and break it down line by line. We'll first start off by talking about the first line on here, which is new web3.eth.contract. Just a moment ago, I had explained to you that the Web3 library is not only intended for use with Ethereum, so it can be used with other types of interesting web technologies as well. In this case, we are accessing the Ethereum module, and in particular, we're accessing the contract property. Contract here is a constructor function, and its intent is to allow us to either interact with existing contracts that exist on the blockchain already, or to create and deploy new contracts. The first argument to the contract constructor right here is our ABI. Remember, the ABI is how we get some intermediation or some conversion or some interface between the Solidity world and the JavaScript world. You'll notice that I said json.parse here and passed in the interface property. When the compiler, the Solidity compiler, compiled our contract and it spit out that interface, it spit out a JSON representation of our interface. We don't want to pass JSON to contract right here. We want to pass an actual JavaScript object. And that's why we specifically parse that JSON to get back a JavaScript object. So this first line in total essentially tells Web3, hey, there's a contract out there and here's the interface that it expects. That first line says nothing about whether this contract has been deployed or whether we're trying to create it. It also says nothing about the data that exists inside the contract. It says nothing about a specific contract. This first line really just tells Web3 there is a type of contract out there that kind of has this interface that you can conform to in order to communicate with it. The second line is where things start to actually get interesting. So once we have this generic contract object at the top, we then customize it a little bit by chaining on these additional methods of deploy and send. The deploy line, as you might guess, is what actually tells Web3 that we want to deploy a new contract. This starts to create a transaction object that has the data property. You'll recall that data is where we specify our bytecode for the contract. And it also has the arguments property, which you will recall is a list of arguments to pass into the constructor function of the contract when it is created. So this argument right here, the first argument in the arguments array, will be received into our contract, our inbox contract right here, as a constructor argument for initial message. The reason that arguments is an array is that the constructor function could potentially accept multiple arguments. So if we had another argument to this thing of like string, I don't know, creator or something like that, then we could have passed in a second element inside of that arguments array. So we could have passed in another element right here, and that would be received into our constructor function as the second argument. So essentially one-to-one mapping from the arguments array to the list of arguments that the contract constructor function expects. Now the last line is what actually takes this idea of a contract that has been customized with some amount of code and deploys it to the network. So calling deploy doesn't actually deploy anything. Calling deploy starts to create an object that can then be deployed to the network. It's the send method that actually triggers the communication from Web3 off to the network. The send function takes both a from property, so this is the person or the account that is being used to create the contract, and then the gas property, which we had described a couple of videos ago. So this is pretty verbose, but this is what goes into the creation of a deployed contract. Now, while we're talking about Web3 and contracts in general, there's one thing that I want to make really clear, because this is something that is kind of challenging to understand when you're just looking at the Web3 documentation. All right, so here's what it is. The Web3 library is not only for use in deploying contracts. We can also use Web3 to get access to contracts that have already been deployed to the network. And in fact, we're going to do that many times throughout this course, because eventually we're going to deploy a contract and then try to interact with it after the fact from some JavaScript application. So we've got two sides to the coin here with Web3. We can use Web3 to create and deploy a new contract, or we can use it to kind of assume or get in touch with or communicate to a contract that has already been deployed. Depending on what we're trying to do, we need to have different amounts of information. If we are trying to interact with a contract that has already been deployed, we need to know the ABI so that we can translate what the contract is trying to do over to JavaScript. We don't need the bytecode in this case because we're not trying to understand what the contract is doing internally. We're just trying to interface with it in some fashion. So if we are just interacting with a contract that has already been deployed, we don't need the bytecode. And then finally, if we're trying to interact with a contract that has been deployed, we need to actually know where that thing has been deployed to. So we need to know the address. Remember, any contract can be deployed an unlimited number of times. So whenever we want to talk to a specific address, or talk to a specific contract, we have to provide the address that that contract has been deployed to. If we are trying to create a contract, which is what we are doing right now, we need the ABI, we need the bytecode, because this is what actually says what the contract does. But in this case, there is not yet an address in existence. We don't yet have an address. So we don't need an address in this case. Once the contract has been deployed successfully, then we will get an address back. And that address will say, hey, here's where the contract exists. All right, so again, that's just a thing that I want to throw out there that can be kind of confusing when you just read the Web3 documentation. Now, the last thing I want to remind you is that whenever we deploy this contract, that is an asynchronous operation. That's why we put the await keyword right here to make sure that, hey, we wait for this thing to actually be deployed successfully. The value that is returned from all this is a direct reference to the inbox contract. So we look at this value right here. This is like our JavaScript representation of the contract. We can interact with this object and call functions on it that actually correspond to the contract over here. So in other words, this object right here represents what exists on the blockchain. We can call functions on it to interact directly with the contract that exists on the blockchain. And we're going to see examples of that very quickly as we start to write some more tests around that thing. Now, the last thing I want to do is a quick review of what we just saw console logged at our terminal. So I just want to step through a couple of properties that are on here to give you a better sense of that inbox object. So I'm going to scroll up to the top of the console log. Here it is right here. So this is an object of type contract. This is a contract that has been constructed by the Web3 library. You're going to see a lot of different pieces of information about things about the provider. So remember, the provider is the communication layer with the actual blockchain. You'll see some stuff around request manager. This is tied to the provider, and it helps facilitate communication with the actual blockchain. Very interestingly, you'll also see a list of providers right here. So whenever we provide a provider to Web3, there are three types of providers that we can designate. It can be a provider that communicates over WebSockets. It can be one that communicates over an HTTP connection, and then one that communicates over IPC, or inter-process communication. IPC is used whenever you are running a blockchain, or a network on the same machine as your test, whatever you're using for your test setup as well. Now, in general, we're not going to have to work that much with some of these different providers, but there are a couple notes that I will give to you over time about each of them. So for right now, I just want you to know that some of these different providers exist. Now we can keep scrolling down a little bit, and I think that's pretty much all I want to point out for right now. There are a couple, here we go. So we see, here we go. My mistake, there's just a little bit more. So the methods object right here, this is probably the most important property on this object that we're dealing with. So methods right here are the actual functions that we can interact with that are tied to our contract. On the methods object, you'll see a property called setMessage and a property called message. These are both functions. So we can call both of these. They will have the exact same effect as when we had been working with this contract over in Remix. You'll recall over here, after we deployed a contract, we could click on either message or setMessage to interact with those functions. Clicking on these buttons is the exact same thing as calling setMessage right here and calling message right here. So we're going to be using these methods quite a bit in just a moment to write some actual functional tests around our contract. Now, I think maybe the last thing I want to mention here is the options address. Options contains some information about the actual contract that was just deployed. And most notably, it contains the address property. You'll notice that there is also an underscore address property right here, but usually by convention, we get access to the address by looking at the options.address property. So again, this is the address that the contract now exists at. Recording the address right here is eventually going to be important when we start to deploy our contracts to the main network. Of course, once we deploy a contract, we want to know where it exists on the blockchain. And so we will want to get access to the address right here. But for right now, for just the purposes of writing some tests, well, not quite so important, but we might write 1 or 2 tests just to make sure that the address exists. Okay, so that's a little bit of an overview on the code that we just wrote. I know that we're going kind of slow right now, well, actually really slow, but this is some of the biggest complexity around Ethereum, so honestly, I'm dumping my knowledge as fast as I can. Hopefully it's fast enough for you. So let's now continue in the next video. We're going to start to write some actual meaningful tests around our inbox contract. So I'll see you in just a minute.